Hello, today I'll be going over 1.1, which is rectangular coordinates. So let's start with naming the quadrants. In the top right corner we have quadrant 1. And here the x values are positive, so they're greater than 0, and the y values are also positive. Quadrant 2 is the top left corner. Here the x values are negative and the y values are positive. Below that is quadrant 3. Here the x values are negative and the y values are also negative. And in quadrant 4, which is the bottom right corner, the x values are positive and the y values are negative. Okay, so you want to determine the quadrants in which x and y is located so that the conditions are satisfied. So for the first one, it says x is greater than 0 and y is equal to negative 27. So if we look at our quadrants here, x is positive in quadrants 1 and 4, and since y is a negative number, that means only quadrant 4 will satisfy the conditions. So this will be quadrant 4. Number 2, it says x is greater than 5. So again, we want x coordinates that are positive. So that'll be quadrant 1 and quadrant 4. But this time there are no restrictions on y, so it would be both quadrant 1 and 4. Next, it says x over y is less than 0, so that means when we divide, we want a negative number. So that means x and y have to be opposite, they can't have the same sign. So it can't be in quadrant 1, it can be in quadrant 2, it cannot be in quadrant 3 since they're both negative here, and negative divided by negative will be positive. But quadrant 4 is fine as well. So it's going to be in quadrant 2 and 4. Okay, next we have the Pythagorean Theorem. So this is for right triangles only. It shows if you have points for a right triangle. The equation is a squared plus b squared equals c squared, where c is the longest length. And here's the distance formula. So if you're given the points x1, y1, and x2, y2, you can plug it into the equation. The distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. So in this first section, we want to show that the points form the vertices of the indicated triangle. So number 4 says right triangle. And to keep things a little more organized, I'm just going to call this A, B, and C, just so I know which side lengths I found. So first, let's start by finding AB. So we're going to plug this into the distance formula because we want to find the lengths of each side. So this would be 3 plus 4 squared plus negative 5 minus 4 squared. So next we're going to simplify the numbers inside the parentheses. So we get 7 squared plus negative 9 squared. So 7 squared is 49 and negative 9 squared is 81. And 49 plus 81 is 130. And now let's see if we can simplify this radical. 130 can break up into 13 and 10 can break up into 2 and 5, but there are no pairs, so that means no numbers can come out of the square root. So we can leave it as square root of 130. Okay, next let's find the length of BC. So this would be the square root of negative 4 plus 4 squared plus 4 plus 5 squared. Negative 4 plus 4 is going to be 0, so 0 squared plus 4 plus 5 is 9. So that means BC is the square root of 81, which is 9. And the last length we have to find is AC. So this is going to be the square root of 3 plus 4 squared plus negative 5 plus 5 squared. So that'll simplify to 7 squared plus 0 squared, which is 7 squared, or 49, and this will equal 7. So we have these three lengths, square root of 130, 9, and 7, and we want to show that it's a right triangle. So in order to do that, we're going to plug this into the Pythagorean theorem. And the longest side is the square root of 130, so that's going to be our C value. So 9 squared plus 7 squared equals square root of 130 squared. That's 81 plus 49 equals 130, which is true, so we just proved that this makes a right triangle. Okay, next we want to show that this is an isosceles triangle. So again, I'm going to call this A, B, and C, just so I know which side lengths I'm looking for. So for AB, this is going to be the square root of 4 minus 2 squared plus 2 minus 1 squared, which is going to be 2 squared plus 1 squared, which is 5. And then BC is going to be 2 minus 6 squared plus 1 minus 1 squared. So that's negative 4 squared, which is going to be 4. And the last length is AC, which is going to be the square root of 4 minus 6 squared plus 2 minus 1 squared. So that becomes negative 2 squared plus 1 squared, which is square root of 5. So we want to prove that this is an isosceles triangle, so we want two side lengths that are the same. So we have square root of 5, 4, and square root of 5. So that means AB is equal to AC, so that means this is isosceles. Okay, next we have the midpoint formula. So if you're given 2 points x1, y1 and x2, y2, to find the midpoint, you're looking for the average. So you're going to add the two x values together, divided by 2, and same with the y values. Okay, so here we want to find the distance between the 2 points and find the midpoint of the line segment joining the points. So for number 6, to find the distance, we're going to plug this into the distance formula. So that'll be 4 plus 2 squared plus negative 1 minus 5 squared, which is 6 squared plus negative 6 squared. That's going to be 36 plus 36, which is 72. And 72 breaks up into 9 and 8. 9 breaks up into 3 and 3, and 8 breaks up into 2 and 4. And 4 we could break up into 2 and 2. So since we have a square root, we're going to look for pairs. So we have a pair of 3's here and a pair of 2's here. So those will come out of the radical. And we have this 2 on the inside that's left over since it didn't have a pair. So 3 times 2 is 6. And we have square root of 2 left on the inside. So the distance is going to be 6 square root of 2. Next, to find the midpoint, we're just going to plug it into the equation. So that's going to be 4 minus 2 over 2, negative 1 plus 5 over 2. So we get 2 over 2 and 4 over 2. So that's going to be the point 1, 2. Okay, and then the last one, again, we're going to find the distance, so we're going to plug it into the equation. So this is negative 1 minus 5 squared plus 3 plus 4 squared. So that's going to be negative 6 squared plus 7 squared, which is 36 plus 49. So this will add up to the square root of 85. 85 would break up into 5 and 17. And both of those are prime numbers, so we can't simplify the square root of 85. Then for the midpoint, we're going to plug this into the midpoint formula, and we get negative 1 plus 5 over 2, and 3 minus 4 over 2. So negative 1 plus 5 is 4, so we have 4 over 2, and 3 minus 4 is negative 1. And we can simplify 4